Hi Spring fans, welcome to another installment of Spring Tips. I love spring, but it is summertime as I record this, and I was thinking, gosh, what can I do to turn the temperature down? And so I decided to come into this hot studio and record a video for you all. That said, I'm not going to do just any regular old video. I thought today we might take a look a little bit behind the scenes, a little bit lower than the typical Spring Boot application, and look at something called an annotation processor. And that said, huge caveat, not everything we're going to look at today is an annotation processor. I don't even know what to call this category of things, if I'm honest. There's a number of these things that serve everyday developers in their Java code. So this is mostly a Java-centric, Java-focused introduction today, but it'll serve you in your work building Spring applications and so on. So, friends, what are these things? Well, there are some things that the Java programming language lacks, not for want of trying or not for lack of resources or whatever, but just because it doesn't stylistically fit with the intentions of the Java language designers, or it's a niche use case, or whatever. And, some of these things, indeed, the Java language does now support, and so they've since been sort of deprecated in the third-party projects. But suffice it to say, there's always room for expansion and extension. And so the community has been quick to do this. There's even an SPI in the Java technology called Annotation Processors. And this is actually represented by a JSR. This JSR gives you a standard mechanism by which you can extend by code generation and so on, at compile time, the code that gets run when you run your program. These annotation processors are really powerful. Some of them go beyond what the JSR will allow you to do, what the standard will allow you to do. And in that respect, I think some of them are a little dangerous, right? This is where we have to be a little careful. We'll talk about these points and more in just a bit. But nonetheless, I think some of these are really interesting and can be quite useful for people who want just a bit more out of the language when they're building their next Spring application. Let's, as always, dive right in. We'll do this, as always, by going to my second favorite place on the internet, start.spring.io. Okay, so we're going to build a brand new project here. And, I think the first one we're going to look at is a very convenient project called Record Builder. So I'll just call this RB, or maybe just Record Builder. There we go. We're going to use Java 21. We use Maven. And I think that's basically it. We don't need much more to see the possibilities. So this project is a third-party project that allows you to build records. Now, this is a feature that's useful if you're using Java 16 records, right? Records are really, really nice because they give you a consistent syntax by which to define sort of immutable data carriers, right? I've talked about them often, and the Java language team has talked about them often in terms of tuples, right? So imagine I have a type here called customer, and it's got an ID and it's got a name, and so on, okay? And I want to work with that. And this is not so bad right here, right? You can imagine at ID if we have a Spring Data JDBC or MongoDB or something like that. This is not so bad, and it's pretty easy to clone these types. You can just copy and paste the parameters from the original and use them to create a new one, right? So let's try that out. So I can create a customer here, new customer. Let's say it's 1 and the name is Josh, okay? Now what if I want a duplicate? Well, I can, one thing that's worth remembering, of course, is that we have this very nice syntax here for an entity, and this object is a carrier of typed data, integer and string. Java is a nominal language, so it has a name, so customer is the name of the tuple, but it's basically a tuple. And the language, if you're willing to agree this contract, that, records have a certain contract, that is to say, data that goes in them are the only state that the thing can have. There is no derived state. And in exchange for that, the language knows how to deconstruct the object and create its own instance of it for you. And it can do things like toString equals hashcode, etc. So equals hashcode, etc. It even creates a constructor, and it creates accessor methods like this, right? So I can read the data. I can't mutate the data, which does get us to another point, which is, let's say I did want to mutate the data. Well, I would have to clone it, right? I'd have to create a new one. So var duplicate customer equals new customer. And I'll take the old customer's ID, but let's say I change the name to be Joshua. Okay. Now this is very tedious because, I've only got 2 fields here, and you can see that wasn't particularly pleasant. But imagine if I had 10 or 20 fields, or even, just more than this, right? Even if they're nested fields, there's still just a lot of data to be moved around just for me to surgically update one bit of the object. So one possible thing that's been bandied around is the idea of a wither. And I don't know what the syntax would look like for this, but the idea is that the language would give you, an extension automatically, and you could just pass in this. You could take the existing one right? I could take customer dot with name, right? And that would be a builder style. So you'd get the updated customer like that. But it would be the same as this, but with one extra thing, which is that the field for the name has been changed, right? But that doesn't exist just yet. So is there a way we can get some of that functionality without having to wait? Well, yes, there's a nice project called Record Builder. And that's this project right here, right? It's this nice, it builds a companion builder class for Java records and an interface with copy methods. And it provides an annotation that generates a Java record from an interface template. So there's a lot of features here. I'm not going to go into all of them, but let's just try this simple example, Record Builder, okay? Take that here, paste that in. And of course, in order for this to work, I do need the Maven dependency. So where is this? It's down here. Add this to your build, and recordbuilder.version, you can find it by looking at the releases here. It's 42, so nice, 42, Command-Shift-I. Do we want that? Okay, there's the record builder. Now, can I use that already? Let's try it. Customer dot, no, not yet. I need to actually customer record builder. Nothing's there yet. So let's go to the build and manually force a compilation of the code. All right, good. So now, if I go here, re-import this, do I get a customer builder? There we go. And now I can build a customer from an existing one like this, and I can specify the name as Joshua, right? And so what does that give me? If I assign that, it gives me a customer builder. I can do .build, in which case I get a customer record, okay? So that's very convenient. That's much more concise than duplicating a thing. And it's type safe, right? So I get this nice validation there. I can create a customer builder, right? So let's say I actually wanted the wither style syntax. I actually wanted exactly that. Well, I can do that. I can extend this record and have it implement customer builder with. Now I've got this implement, and now I can say Joshua.with name is Josh. And maybe I want to change the ID for some reason. Let's do that, right? And I can make that too. And so I get back, as a result of this, a clone, right? Updated with withers. System out, updated with withers. Let's run this and see what we get. All right, look at that. I got ID2, name is Josh. Pretty convenient. So you can do it both ways. You can have the builder, or if you want to have your record implement this type, you can also get the wither syntax. Either way, this is all being done at compile time. Really, really efficient. Very, very nice. So now this is a simple project. It just adds something that I think a lot of people wish they had in their existing records. Remember, I love records. I use it all the time. If you're using any of the Spring Data projects, save, of course, for JPA and Hibernate and the like, you can use records. I use Spring Data JDBC all the time. And, you know, it is a bit of an anti-pattern if you have too many fields in a given entity. So I try and keep that in mind when I design my tables, my schema, and so on. But that said, if I could just make even the work of moving just a handful of fields around easier, so I don't have to duplicate manually all the data, then this would be a real win, a real time saver. So this project has a special place in my heart. Another very interesting thing to note is that if you add the Spring Boot support for Graalvm native images just by configuring the Graalvm native Maven plugin, you can actually turn this into a native image, right? So if I run this, all right, the compilation's finished, go to target, and then run the native image, you get a program that has wither support and works as a Graalvm native image. Because again, a lot of these are doing code generation through the JSR, and that's a standard mechanism, and it works just fine. So, you know, your mileage might vary. Some of these things are not exactly, strictly speaking, using standard interfaces. But for records, this one seems to work just fine. All right, let's move on to the next really interesting project, arguably the elephant in the room, Lombok. Let's go to start.spring.io. We'll add Lombok here. Add Graalvm native image support. Hit generate. Here we go. All right, here's my application. Let's imagine I just have a class, not a record, right? Okay, and I want to create a customer, and it has a private final string name, private final integer ID. Add these constructor arguments. Now I want, I can generate that. I can go ahead and generate the getters for that. I can create the equals and the hash code for this, right? All the stuff you can do in Java, but it's very, very, very tedious. So Lombok has a lot of really nice annotations. One of them is the no args constructor. The other one that I use is required args constructor, right? And what this will do is it'll generate a constructor for you based on the final fields, right? So here's this, and I can say var customer equals new customer, 1 Josh, okay? Customer dot, you can see I've got a constructor, and maybe I want a constructor as well as some getters. So I could use @getter, right? I can say customer dot get ID, get name. Okay, fine. Maybe I could use at toString, to have it generate a nice toString for me. So toString, let's print that out. Okay, gives me a nice toString. And, maybe I want other things. So actually there's a lot of things you can get. And there's even a meta annotation called data, which gives you all the things I just showed you and then some, right? So I get the nice toString, the equals, the hash code, etc. So this, in turn, if you look at it, it does getter, setter, required args constructor, toString, equals, and hash code, and then add value, okay? And add value helps you, it's equivalent to getter, field defaults, make it final, make it private, all args constructor, toString, and equals, and hash code. So very, very convenient annotation. There's a lot of other ones. I used to use Lombok all the time, and there's one of my all-time favorites is this one. I just hate creating loggers, right? So I could just info hello world, right? Just configures it for me just by adding the annotation to the type. Very, very convenient, right? But I don't use it right now. This is arguably the most famous and the most well-known of these tools that we're going to look at, but it's arguably also the most sort of insidious. People really hate having this in the code because it means you have to have annotation processing enabled. It disqualifies some tooling from working with this code base. It works just fine here in IntelliJ, but again, I'm using the paid IntelliJ version. Your mileage might vary elsewhere. And also, it's not strictly speaking using the standard mechanism. It's actually, the Java language team has talked about this. They've talked about why they would prefer people didn't use Lombok, because it is a bit more like a compiler, not a APT processor, right? It's actually a secondary compiler, and it's relying on things that may or may not exist in the future, right? And that can't be guaranteed to work. And so the argument goes, this is setting people up for a bit of a disappointment, if not a rewrite, right, in the future. So I would encourage you to keep that in mind when using this. There is also, by the way, if you ever get to a point where you can't trust Lombok to be the thing you want, you can de-Lombokify your source code. So basically you configure this plugin and it'll dump out the actual generated source code for you. And you can then sort of integrate that into your code base and then remove the dependency on Lombok, which I think is a pretty good hedge against any kind of situation where you are in a bad place, right? I'm not sure if this plugin exists for Gradle, or Gradle. Certainly it wouldn't be that hard to get a Gradle code base moved over to Maven just well enough so that it compiles and then you can run this plugin against it. But again, hopefully you don't need that. If you liked Lombok, and I can't blame you for liking it, then you might love the next project. The next project is called Manifold. It's a metaprogramming plugin. And yeah, it takes Java places I didn't know you could go, right? It is properly magic in what it can do. It makes it a different language, in effect. It's not just some annotations sprinkled here or there. This is doing some absolutely ridiculous things. And you can see it's got metaprogramming. You can use the framework to gain direct type-safe access to any type of resource, such as SQL, JSON, GraphQL, XML, YAML, and CSV files, and even other languages like JavaScript. You can use native SQL of any complexity directly and type safely from your Java code, right? So here's the query. Language is English. You can say select all from language where the name is equal to English. You can build up a query builder. You can build up a builder to query a movie and then request it from the GraphQL endpoint, get the results back, and then iterate over them and then print them out. You can use JSON schema and literally just a JSON file sat in a folder and treat it like a type-safe type and then use that to initialize and construct new instances of it. And you can add new methods to existing types, kind of like extension functions or extension methods in other languages like Ruby and Kotlin. So it's a really, really amazing property and technology. Let's get a simple example going because it's anything but simple to get it going. So we'll go over here. We're going to create a new project, Manifold. And again, actually, I don't even know if GraalVM works. We'll try it later, I guess. Let's add that, Java 21, GraalVM. Okay, we have this zip file. Let's open that up in our IDE. So there's Manifold ships with a number of different modules. We're not going to use all of them. Let's just bring in a couple that I find really interesting. We'll bring in the Manifold Science and the Manifold Tuple support. This in turn requires a version of Manifold. I'll specify that as a property up here, manifold.version 2024 1.0. And of course, all of this requires some configuration in the build plugin. So I'll go down to our plugins area and specify all this. So here's the Maven compiler plugin. I'm specifying I want to use UTF-8, specifying that I want to use the Manifold plugin. I want to enable preview features, show the warnings, sure, and then add to the annotation processor path the systems manifold tuple runtime support, right? All right, so we've got that now. Let's try it out. First things first, Java has records, which are a bit like tuples, but other languages have tuples, which are like records, but without a name. Well, now, thanks to Manifold, you can have the same thing as well. Mind you, I have a plugin installed to support working with Manifold, right? So if I go to Manifold here, I have an IntelliJ plugin that I had to install. It's free, but it's required for this to do what it's going to do, okay? So let's say I want to create a named tuple, okay? Well, I can just say name is equal to Josh, and then age is 40, okay? And name tuple has an age field and a name field. So I can actually print that stuff out. I can say name tuple dot name tuple dot age, right? Now you can see the compiler's not too happy with what's going on here. It doesn't know why I have this weird syntax. And that's with the plugin enabled. One imagines it'll get better. It usually does, but you just have to trust that it's going to work. Go ahead and run. All right, there we go. Josh 40, right? So and there you go. One compile later, the plugin seems to have sorted things out. So it's a little fragile, okay? This is definitely taking Java into new territory, that's for sure. Okay, you can do other, without named attributes. You can just say, tuple equals 1, 2, 3, right? And I can then print out tuple dot item 2, which we expect to be equal to 2. There we go. It's amazing. Okay, what else? You ever want to get access to a field that you can't otherwise get access to? It happens a lot, right? In the first early days of Spring Cloud Netflix, when we were supporting Eureka Server in Spring, embedding and then standing up Eureka Server in Spring, for example, there was a field within the Eureka class, in one of the classes in the Eureka project, that we needed access to that was not visible in any other way, save for this nasty, well-demarcated hack that we had to do using reflection and making something visible and accessible. Well, now, say no more. You don't have to worry about that. So privacy be gone, and private int random number equals math.random times 100, 1,000, and then we'll make that a double, okay? So now let's suppose I want to access an instance of that. I can say privacy be gone equals new privacy be gone. I'm going to use @jailbreak. I'll print out privacy be gone dot random number. Oh, you might notice this isn't going to work. There you go. I have to actually specify the type. This is weird. It doesn't work with Java's var syntax. You have to specify the type here. Okay, so that one's on me. I don't know why that happens, though. It feels very inconsistent, but you get the idea. There's my random number, which, again, as best as I could, I made that private, right? It's not about visibility or scope either. I can just try again, and I still have access to it. It's just very, very strange feature, but hey, you ever have to do calculations as in, math and science? Well, you can do that in Java now. Not just regular simple math, but I mean math having to do with units of something. So let's say I want to find the distance in miles, or freedom units, right? So distance in miles equals 2 times 2 mile, okay? And I'm going to print that out. What is that type, by the way? It's a length. Okay, what does that give me? So let me print that out, okay? It's 4 miles. What about in kilometers? I get a length when I do that, by the way. I love that. Okay. And there's all sorts of other ones that you can use that are different units. You have miles, you have temperatures, you have all sorts of cool stuff in there. Now, one wonders what happens if you do miles times kilometers. So if I print out distance in kilometers times distance in miles, does the world explode? It doesn't make any sense. I don't know what that is. That's weird. I don't know what I just got back there. So if I assign these two things to a variable, oh, it's an area. Oh, look at that. An area, even crazier. That's really cool. So area dot, and then I can get the base unit and all that kind of stuff. Very, very cool. Okay, so you can see there's some really interesting possibilities there. And you notice that also we're multiplying objects, which gets us to yet another feature that Manifold supports, which is operator overloading. If you look at the length type, you can see that there are methods, well-known method names, that if you implement them, automatically translate into extensions to the operators, right? So let's try that out over here. Let's say I want to have a cart, and I'll have a record order, string skew or something like that. And I'll say public cart plus order. And I'll have a set order. Okay, private final. Sure. This dot orders dot add order, return this. So now if I create a cart down here, I can say cart dot new order 1. Okay. And I've got that in a set. So now maybe I should have made this, maybe I could use a jailbreak. So I want to print out those orders. Let me make that a type. I'll jailbreak it again. System out cart.orders. Look at that. 1, 2, 3. There we are. There's our set. So you can do some really amazing things with the Manifold project. Okay, obviously you saw it's a little fragile and there's some weird idiosyncrasies like the jailbreak only working on variables without var and whatever. And again, I would be very leery of what this experience is like in something besides IntelliJ with a supported version of the plugin, with a supported version of Java. But hey, if you really want these features and you can't move to Kotlin, you might be in luck. Now, the next one I think is a really useful one for a lot of sort of data access scenarios as well. I think in terms of the average data-centric developer's life, the record builder and this one are going to be the most useful sort of on day one, right? MapStruct is a way to map objects into other objects. And this happens a lot. If you ever had to create a DTO, a data transfer object, this is particularly useful. You might be wondering, why do I need this? Why do I need to have two objects that are basically the same? And the answer is, I don't actually know. And then it took a little while for me to kind of imagine where people might benefit from this. And it turns out there's actually a lot of places where that might be more useful than I thought. One of which is when using JPA. Remember, when you use JPA, you get these objects that look like plain old Java objects, but they're actually very magical. They have a lot of like session state that's tied to each instance. And they don't work particularly well outside of the confines of an ongoing transaction or session, right? And so it becomes very useful to then have a way to turn those entities into an object that you can then be assured is ready to be serialized across the network boundary, right? As JSON, in a template or whatever. And so details are very good for that. You don't want to leak the implementation details of your persistence layer to the view layer, right? The fact that using JPA is the thing you're doing in your persistence layer, that shouldn't be something that your UI layer needs to care about. So MapStruct is pretty useful. Let's go ahead and figure it out. So we'll go here, start testing today. We'll generate a new project, MapStruct, and just hit generate MapStruct. All right, so let's imagine we have an application with a type of record of type customer, okay? Or even a record, by the way. This isn't, strictly speaking, tied to regular objects. Integer ID and string name, okay? So again, I'm keeping it nice and simple. And let's say I have another type that I want the user to get. And so I want it to be visible. So maybe I only need send the ID. I don't want to send the name, okay? And I can create a mapper. So I can say customer mapper, and annotate it with @mapper but first I need to add the MapStruct dependencies to the build. Let's paste this in here. And then of course we need to configure the build plugin. Let's do that here. So here I'm saying use Java 21, use MapStruct processor, add this to the class path, etc. I'll re-import this. I'll re-import it. And now, if I go back here, I get a mapper, and I can create a customer mapper instance equals mappers.getMapper for a customer. And then I can have a method here to go from a customer to a customer DTO. So customer to customer DTO, pass in the customer, and I'm good. So now in the code, let's say, I can just get the instance. I can say customer mapper dot instance dot new customer. ID is 1, and the name will be Josh, let's say. Now I've got a customer DTO, right? And I can now print that out. And remember, we didn't have any affordance for the name, so that shouldn't be present in the resulting DTO object. And there we go. ID is 1. So it automatically matched similar things to similar things. There are many annotations that you can use to tell it what to do in the case of a missing or a misaligned field. You can tell it to target a particular field given an input field and so on. There's a lot more control here than what I've shown, but this goes a long way. You can even there's even integration with Spring, so you can have this as a regular bean, right? In practice, you can imagine that wouldn't be that difficult to do. Just define a bean method that returns the instance and you're off to the races. But I think this is a very useful project for people that have this situation where they want to have a DTOs and they want those DTOs to be similar to their objects, but not exactly the same, and to provide a client boundary. So MapStruct project makes it very easy to create a mapper and to automatically create DTOs and transfer objects and just generally map objects from one thing to another with ease. This can be used for example, in setting up forms where you need to have pre-populated fields on the server side, to doing DTO objects for views and HTTP endpoints and the like. Really just a very useful project, kind of convenient, not a pain to use at all. And there's even integration with Spring so that you can have this type the customer mapper set up as a singleton that you can then inject, as opposed to having this singleton instance here. I'm a big fan. Really very useful. And if you have the use case for it, it's not a pain to add it to your project at all. Very good. All right, Spring fans, thanks for watching. I hope you got something out of this list here. Obviously, we've only begun to scratch the surface. There are a good many different annotation processors and things of this sort that can make your life easier without you ever having to write a line of code. Or if you do write a line of code, it's very much a sort of asymmetric sort of thing where you write an annotation and then it writes whatever, gobs of generated code for you. So it's a win-win all around. It's nice to feel like the compiler is doing some of the work for you whenever it can. Thanks so much for watching. As always, stay tuned. See you next week. And by the way, I'd love to know what other annotation processors you use. Are there some that I missed? I'd love to hear your comments. Sound off in the comments and tell us which ones you like or don't. Okay, bye. Bye.